make a video about this thing, about the stresses in load due to preload. So without preload, what is happening? First, see, without preload, it is happening that there is a shear, two side has shank and shear. This is the shank. The diameter of the shank is ds, diameter of shank 5/4 d square, and this is the bolt. Bolt can shear, this is 5/4 d square c. This is the bolt and this is the shank. This is the shank part which can shear, this is the bolt part which can also shear. So whatever may be. So next thing that I want to pay attention is that the preload external load. So there is a 3 bar. So K equivalent is 1 by K1, 1 by K2, K3 we are writing. So this is the connecting member, this is the bolt B. Okay. This is delta M. Delta M is the deformation initial stage due to compression, and delta B is the deformation due to preload. So delta B in the bolt due to preload that is happening. So now this is the member, this is FC. There is a FC force that has been here. It is the external force that is being applied. So it is like pulling this thing from both ends. So what is happening? There is external force that will happen. Okay. So due to this, so F external equal to FCM, that is the connecting member force, plus this is the bolt also pull, na? So bolt also pull this side, plus FB. So that's what happening. So load due to bolt and due to connecting member, that is happening. And delta M deformation for the due to F deformation, what kill hai? F equal to K into delta X. That's how we can see F equal to K by FCM by K equivalent by FCM by K equivalent by FB by KB. Okay, now delta M equal to delta B, like delta M deformation, how much is delta B deformation? Also connecting member deformation and bolt deformation same. So FC by K, FC by same here, FC equal to KCM by KB dot FB we are getting. Now FC value, we are just putting this value KCM by KB into FB dot FB taking common out, then this value, and FB we are just writing. So force in the bolt would be KB by KC plus KM plus KB into F external. So we can also write FB equal to C into FC, and this whole part we are writing is SC. This whole part we are writing is SC, and FC external equal to FCM plus C into FC. So FCM equal to, we can write 1 minus C. FCM equal to 1 minus C. From this side we can load without any pretension. This is happening, and with pretension what will happen is that when we are decreasing initial pretension, so first resultant force on the bolt, so FB this side, this is the force is acting, and initial pretension also acting this side. So these are adding up. So Fi plus C into FC we are getting, and then in the connecting member this is happening, this is side here loading, and this side connecting member has been pulled. So A minus Fi plus 1 minus C, FCM equal to 1 minus C into FC likhte pari. So FCM equal to 1 minus C into FC we are getting from there, and we are just putting this value. So now the main point that really important, that is for a leak proof joint, the value of RCM, the connecting member resultant force, resultant force has to be less than 0. RCM is less than 0, then Fi equal to 1 minus C into FC. So Fi equal to 1 minus C into FC. Important is that if RB equal to Fi into C minus, so minus Fi 1 minus C into FC, C equal to KB by K plus A. That's how. So KCM value is decreasing, C value is increasing. So not with preload, without life more. With preload and without preload, which is more life we are getting. Source which is external load, pressure P equal to F by pi by 4 d square, P equal to we are getting. So RCM less to be. So that's how the load in the preload has completed. So this is the part. Then we are just going to the eccentric loading, and after that this chapter is complete fully, and after that you don't have to just revise each and every day. You are just making every day, making you understand those things in a really great manner. Okay.